Hello, Mario! In this video we're going to take a look at a little more complex problem with the milk balancing situation. So we've got 80,000 kilograms of whole milk testing at 4.1% fat, and that's to be separated to give cream testing at 42.5% fat and standardized milk with a fat test of 3%. So we need to calculate the amounts of each standardized milk and cream produced by the separation. So although everything balances out here, we don't quite have the quantities that we had previously. So let's have a look at this. First of all, we can work out the total fat, which is just the percentage of that times this here, enter, which we can do on our little calculator here pretty easily. All clear. 80,000 times 4.5, and I'm going to use shift percent equals 3600. So we can do that all right. Now what we know is whatever the cream is, we're just going to give that a letter of C for cream, because we don't actually know what it is, but we do know that it's 42.5%. Okay, we know that it's got 42.5% fat, the cream of it, and the skim milk. We just want to use one variable really, so we don't want to create another variable called S or something, because we know that the skim milk has got to be 80,000 minus C, whatever the cream is. That's going to be our skim milk, and we know that that is 3%. So that's at 3%. Now obviously we've got some things in here unknown, C, that we don't know. But what we do know is that if we take 42.5% of C, we can write that down as 0.425 C, okay, as by way of a formula. So we've got 3,600 is going to equal 425 C, and then it's going to be 3% of this here. So just quickly on the calculator, if we get our little calculator out, which unfortunately has disappeared, so I'll have to just go and seek it out. My little calculator, it decided to go to bed early tonight, so there we go. Anyway, it's back. Don't worry, we've got it, we've found it. So it's just a little thing there. So if we do that, we can just see that we've got 80,000 there times 3%, 3%, 3%. Didn't like that. Shift percent equals 2,400. But there's also 2,400, but it's minus 3% of C, which is 0 points like that. So it's 2,400. So now what we can see here is that we've got 3,600 equals 0.425 C plus 2,400 minus 0.03 C. So what we can see here is that we can have 1,200 there, because that's 3,600 minus 2,400, put that over there, equals 0.425 C minus 0.03, which is 0.395 C. 0.395 C. Okay, so that enables us to work that out. That's a little calculation there. So from that we can see that C is going to equal 1200 divided by 0.395. Okay, 1200 divided by 0.395. I might write that down, 1200 slash 0.395. Okay, so and C will then equal, I'll just do it here on the old spreadsheet, equals 1200 slash 0.395, and that gives us 3037.97 kgs. It's all in kgs. And then of course we know the skim milk is just going to be 80,000 minus that, plus 80 minus that, and that's going to be our skim milk there, which is 76962.03, and we can just do some little checks. We know that's going to add to 80,000 there pretty simply. We know this here is going to be 3600, and we can just add these here just to check, and they should add up to 80,000. So yeah, the 80,000 kilograms of whole milk will be made into 3,037.97 kgs of cream and 76,962.03 kilograms of skim milk. So the thing here is to select, the key here is the selection of the correct variable C, and then only using one unknown. So if C is the cream, then the skim milk will be 80,000 minus C. We then multiplied the percentages out there to give a little equation here that we knew equals 3,600. And then we can take the 2,400 off both sides, and that gave us C, and we can divide through by 39.5 to actually find out what C is. We can then apply that back to the 80,000 here, and that's how we get everything worked out. So yeah, it's not too bad. Pretty good. Cheers. See you.